Hello and welcome. Today, we're going to dig into a question that sounds super simple, but the answer, well, it's pretty fantastic. Why do we have seasons?
I mean, we all feel it, right? Those long, amazing summer days that are just made for cookouts. And then, on the flip side, the cold, short days of winter that might bring a snow day if you're lucky. But what's really going on a huge planetary scale to cause this massive shift every single year?
Now, the explanation you hear all the time, the one that a lot of us were probably taught, is all about distance. It seems to make perfect sense, doesn't it? When the Earth gets closer to the Sun, it's summer. When it's farther away, it's winter. It's logical, it's simple, and it's totally, completely wrong.
Yeah, the real reason we get to enjoy spring flowers or go skiing has absolutely nothing to do with our planet cozying up to the sun. The true story is way more interesting, and it all boils down to one simple thing: a tilt. Okay, so if it's all about this tilt, what does that even mean? To really get why we have seasons, we first have to understand how our planet moves through space. So picture this. A basketball player is spinning a ball on their finger. That ball is spinning around an invisible line that goes right through the middle, from the top to the bottom. That imaginary line, that's called an axis. And our Earth has an axis just like that basketball. It's an imaginary pole sticking right through the North and South poles. And our entire planet spins around this line about once every 24 hours. But there's a really important difference.
And that crucial difference, it all comes down to this one number: 23.5 degrees. Seriously, this number is the key to everything.
See, unlike that perfectly balanced basketball, Earth isn't spinning straight up and down as it goes around the sun. Our planet is permanently knocked over on its side, tilted on its axis by 23.5 degrees. And that little tilt is what decides if you're wearing shorts or a winter coat.
So how can a little tilt change so much? Well, it's all about how the sunlight actually hits the planet. Think of the sun's energy like it's a flashlight beam. When part of the Earth is tilted toward the sun, it gets hit with direct, focused rays, just like pointing a flashlight beam straight at a wall. All that energy is concentrated in a small spot, so it's a lot of heat. But when that same part of the Earth is tilted away from the sun, it gets the same amount of light, but it's spread out over a much bigger area. Those are indirect rays. It's like shining your flashlight at an angle. The light is weaker, more spread out.
Okay, so we've got the tilt, we've got the direct and indirect rays. Now let's put our planet in motion and see what happens during its year-long trip around the sun.
Now, this is the most important rule to remember for this whole journey. As Earth goes around and around the sun, that 23.5-degree tilt doesn't just flop all over the place. Nope, it always points in the exact same direction in space, right towards the North Star, Polaris. It's constant.
So let's say it's around June. At this point in its orbit, the northern hemisphere, that's the top half of the planet, is the part that's tilted toward the sun. So it gets blasted with those powerful, direct, concentrated rays we just talked about. The days get longer, the weather gets warmer, and for anyone living north of the equator, hello summer.
Okay, now let's fast forward 6 months. Earth is on the complete opposite side of the sun. But remember, that axis is still pointing in the same direction in space. So now, the northern hemisphere is tilted away from the sun. It's getting those weak, spread out, indirect rays. The days are short, it's cold, and boom, it's winter. And of course, that means for everyone in the southern hemisphere, it's their turn to have summer.
So what about the moments in between those two extremes? Well, that's what happens in March and September. At these points in our orbit, our planet's tilt is kind of sideways to the sun. Neither the northern half nor the southern half is tilted more toward or away from it. The sunlight gets spread out pretty evenly over the whole planet, and that gives us those mild transitional seasons, spring and fall.
And of course, these key moments have names. A solstice is when the sun hits its highest or lowest point in the sky, which gives us our longest and shortest days of the year. And an equinox is when the sun's rays are shining most directly right on the equator, which makes day and night almost exactly equal in length everywhere on Earth. Pretty cool, right?
So that's the science behind it. But can you actually see these massive changes happening from way out in space? Oh, absolutely. And it's spectacular.
This yearly cycle of direct versus indirect sunlight doesn't just change how warm or cold it is, it literally transforms the way our planet's surface looks.
And here it is. This is what that change looks like from space. These are satellite images of Earth. Over on the left, that's the northern hemisphere's summer in June. Just look at that incredible green up all across North America, Europe, and Asia. It's bursting with life. Now look to the right. That's December. All that green is pulled back, and now it's the southern hemisphere's turn to be lush and vibrant. You are literally looking at the seasons written across the face of our world.
So we've busted the big myth, and we've laid out the real reason for the seasons. Let's do a quick recap, and then let's push this idea just one step further.
All right, so here's the deal, the key takeaways. Number 1, seasons happen because of Earth's 23.5-degree tilt, not its distance from the sun. Forget the distance thing. Number 2, the half of the planet tilted toward the sun gets direct sunlight, and that means summer. And number 3, the half tilted away gets indirect sunlight, and that means winter. It's really that straightforward.
But, it does make you wonder. We've just established that this 23.5-degree tilt is the engine driving our seasons. But is that number just fixed? Is it set in stone forever?
And the answer, when you look at massive stretches of time, is no. Earth's axial tilt, which scientists call its obliquity, actually wobbles back and forth. This graph shows that over the last million years, it's shifted between about 22 and 24.5 degrees. Our current 23.5 degrees is just where we happen to be right now in this incredibly long, slow dance.
And that leaves us with one last, giant thought to chew on. If the very thing that controls our seasons is itself slowly changing over thousands of years, what does that mean for Earth's climate in the long run? It turns out these tiny shifts in tilt, along with other subtle changes in our orbit, are believed to be the metronome that sets the timing for Earth's ice ages. A tiny change in that tilt, stretched out over a very long time, can literally change the world.